Hello and welcome to SudoKanard. In this video I'll be test solving a Sudoku puzzle by Audrin, which was posted on the Cracking the Cryptic fan server on Discord. And it's a puzzle that mixes a lot of different constraints. First, it uses digits from 0 to 8, not from 1 to 9 as usual. And it has a sandwich. There's only one sandwich that is given actually, which has 0 and 8 as sandwich crust, which means basically that in this column 0 and 8 are next to each other. And it has the non-consecutive constraint, which is a very strong constraint. Actually, I've never managed to construct one non-consecutive puzzle just by hand. And there are a few V's and a few X's that are given, meaning that the sum of those digits is 10, the sum of those digits is 5, and there is no negative constraint, meaning that the sum here could very possibly be 10 or 5. And that's all we have with this. Well, non-consecutive is a very strong constraint, so let's have a look. Let's just note that V could be 0 plus 5, 1 plus 4, 2 plus 3, which is one more possibility than the classic XV Sudoku. 10 could be 2 plus 8, 3 plus 7, 4 plus 6, which is one less possibility than usual. Now, what do we have? Actually 2 plus 3 is not possible because of the non-consecutive constraints. So those digits are those ones. So we have, say, something like 0, 5, in which case it's this way 1 and 4. Or it's the other way around, because 0 can't be next to a 1, 5 can't be next to a 4. So that's something to start with. So this is 1 and 4, and now this is one of those, and 2 can't be next to the 1, 3 can't be next to the 4. Oh, and because of this, 4 has to be here. So this could be 4 and 6, or we could have a 4 here and something else here. Now, what else? Those now could possibly be two occurrences of the same. It would probably raise an issue with uniqueness, or not necessarily. If there is a 2 here, then we can have 4, 1, 4, 1. So there's no issue with uniqueness if those are done with the same sum, with the same set of digits, I should say. Now this is not 1 or 4, so those must be 0 and 5. So that could be the counterpart among those digits, or both are 1 and 4. Those digits now must include 4 of those digits. Not sure which ones. And now 5 is usable in this variant. 1 must be there. It can't be here, so 1 is in one of those cells. So we know that 2 is not here. What about this sandwich? We know that 0 and 8 must be adjacent. 0 can't be here, so it could still be 8 and 0, or they could be both in those cells, forbidding 0 from those cells. What about 5? 5 is not here, it's not in the 10 clue, so 5 is in one of those cells. And 5 is not here, it can be here, it could be in one of those as well. If 1 is here, then 0 is not here. Is there anything else with non-consecutive? We know that 6 can't be here, or it would be next to the 5. And 6 can't be here, so 6 has to be here. So now we know that this does not include a 6, nor this. Where's 6? 6 could be any place here. We could have 6 and 4. 4 is not here either. So 2, 8 or 3, 7, but... Oh, and 7 is not here. So 7 could be here, could be there, well... Not so helpful. Oh, this could not be 6 and 4. Oh, because of this, and this 4 is in one of those sets. Now 4 can't be here, so 4 is here. So this one is not 3, but it could still be 3 and 7, or 2 and 8. Actually, 2, 3, 2, 8, 3, 7 are to be in those cells. So those are 1, 0, 8, and 5. 0 and 1 are not next to each other. So 0 is not here. So 0 has to be here. And 0 and 1 are diagonally opposite. And 8 is somewhere. 1, 0 and 8, 5. No, I said 8, but no. 8 is with the 2. What is the missing digit? 1, 0, 5, and 6. Yes, that's 6. So that's interesting. So 0 and 1 must be on one diagonal, and 5 and 6 must be on the other diagonal. And what next? We don't have much to work with, really. I just know that 3 is not here, so 3 has to be in one of those cells. 7 must be here. And this says that 6 is not here. 6 could still be here, with 5 here, 6, 5. Oh no, 5 could not be here because of this. So 6 is not in this cell. So 6 has to be here. Now we know that the scenarios are those. And 6 can't be here, so 6 is really here, with 1 here, 0 and 5 in this order, and 0 in this cell. Right, that's good. And 2 and 8, 2 can't be next to the 1. So we now know that 2 and 3 must be in those cells, together with 7 and 8, like this. That's some progress. What can we do next? 0 is not here. And 4 is not here. So now we know that those digits are 1 and 5. Together with 4, 0. And so 0 is not in those cells. It has to be down there. It could be with an 8 here, or 0 and 8 both in this region, in this block. This 10 now, can still be any of those. 5 is not here, it has to go there. And 6 is at the bottom. Those must be one of those decompositions, and the counterpart is this. So this is 2 or 3. And the other digit 2 or 3 can't be here. They would be next to each other and consecutive, so it must be there. We must have 2 or 3 in one of those cells. 6 is up there as well. 5, 5, 1. And actually the missing pair that adds up to 10 must be here. So this digit must be here by normal Sudoku, together with 8 or 7. So those digits add up to 10. And we have the counterpart of this up there, which is 7, 8, and the third digit is 6. And 6 can't be next to 7, but it could be here and there. So this can't be this digit, so it has to be 6 or 7 or 8. And if this is 7, then this can't be 6, but there's still a lot to resolve. And the counterpart of this, adding up to 10, is here. It has to be 8 or 7. So I guess the sandwich is here will be here to disambiguate all those pairs. That's my bet there. It's been a kind of trend lately. This can't be next to 2 or 3, so 3 or 2 is here, together with 7 or 8, and that works. That works with the nonconsecutive constraint. So 0 and 8 are down there. What else can we do? Now we only have the nonconsecutive constraint to work with, which is a lot, but really not that much. 6 not here. If 5 is here, then 6 has to go there, but 6 could be here with 5, 1. Oh, I had missed that. This 4 makes this a 2, so this is all disambiguated. I can lose a very long time missing those facts. So all of this suddenly becomes fully resolved. Now we must put 6 and 7 in those cells. So 3 has to come between them. And this 3 resolves this. But 6 and 7 still remain to be disambiguated. So we know that 0 and 4 are not here, so that's 0, 8 and 4. 0, 8 in the middle. And 4 outside the sandwich. And let's have a look at what the non-consecutive constraint can do for us. Those are 2, 5, and 7. This is not 2. Those must be 1, 3, 6, and 8. 6 can't go there because of this, so it has to be 1 or 3. And this way, according to both scenarios, this is not 3. It could still be 1 or 8, can't be 6. 6 has to be here. We still need 1, 3, 6, and 7. This is not 1 or 3, so this is 6 or 7. And 6 and 7 are not next to each other, so this is 1 or 3. 1, 3, 2, and 5. 2 and 5 don't give a strong constraint. In this column, and here it must be 3, 6, or 7. It's not a 2, so this is 6 or 7. And down there, 0, 3, 6, or 7, that's not a 3. That's not 6 or 7 either, so this is a 0. Three, 6, and 7. And this is not a 6 or 7, so that's a 3. 6 or 7 here. 1 and 5 must be in those cells, but that's not saying much. Do we get anything else from this? 2 and 5 must still be down there. 3 must be in one of those cells, but where? And 2 can't be next to the 3, so 2 has to be in those cells, not here. 2 is here or there. 1 is in those cells, not next to the 2, but that's not so precise. 5 must be here. 5 and 1. Oh, 3. And 2 is not next to the 3. This is still not resolved. Nor is this. We still need 2 and 5. Already mentioned that countless times. What can this be? Not 0, not 1, not 3, 4, not 6, 7, 8, not 5. Could it be anything but a 2? No, 0, 1, 3. Could be a 4. 2, 4. That's it, only 2 or 4. This is not 6 or 7. Could still be an 8. Could still be 2 or 4. Two, 4, or 8. This can't be 2 or 4. Can't be any odd digit, can't be 2 or 4, nor 0, so it has to be 6 or 8. That's an unusual set of digits to work with. 2, oh, actually 2 and 4 can't be there because of this 3, so this is a 2-4 pair. So 3 is with 6 or 8. Two and 4 are in those cells, not next to a 3. So one of those cells is not filled with a 2 or a 4. One of them is here. One and 5 must be here, but 1 mustn't be next to the 2. 5 can't be next to the 4. Ooh, that's tricky. The other 2, 4 on this row can't be next to the 3. And something nice is that 6 and 7 on this row can't be here or there. They can be here, here, or in this cell. So that's 1 degree of freedom again. 2 and 4. There's one of them here. Oh. Am I missing something with this? There's still a lot to do. I need a second 2 or 4. Yes, it's up there. On this column, we still need 1, 3, 2, 5. So 1, 2, or 5, 2, 3, or 5 here. 3 and 5 would rule out this 4, making this a 0, this a 4. But there's nothing to force 2 out of this cell. Two, with a 2 here, 3 has to be there, and 1 here, and 5, and that seems to work. Yes, that works. What about this row? Not seeing what I could make of it. Did I miss anything? Oh, yes, I've been missing something here. That's very nice. On the left-hand scenario, we have a 4 here, so no 5 there. On the right-hand scenario, we have a 5 here, so no 5 there. And the same applies here, so we have a 5 in this cell. And that's the only deduction, but that's already something very nice, I think. And it has no effect on the rest, but really, I like that logic. We still need a 6 in one of those cells, and it won't be next to this. But that's not saying much again. I really don't see how I'm supposed to get out of this trap. Oh. So 0 and 5 are not here, they're not here either. Something interesting here. If I make this a 0, then this is not a 1, that's a 3, and we have 1, 2, 5 here, so 5 has to be in the middle. And if I make this an 8, then this is a 4, and 5 does not go here. So in both cases, I can remove 5 from this cell. And, oh, and actually, if this is 0, then this is 3, so this is not a 3. And if this is 8, then this is a 4, so this is not a 3 either. So this must be a 2. This is very nice and very well hidden. This can't be 1 or 3, so it has to be a 5. That's a 1, that's a 3. That's not a 0, so that's a 0. That's a 2, that's a 4. Some progress, finally. Very, very neat logic and very well hidden, as I said. This one makes this an 8. That's a 1. So we now get all those digits. And so that's not a 6. And what else? This 4 makes this an 8, this a 4, that's a 6, that's a 7. Here we have a 3 and 6. So 2 scenarios again. In this order. And what more do we have? 5 in this row can only go here. 3 can't go here now. Here. 3 can't go here, so 3 is here, and 5 is in this cell. We still need 1 and 7. And both cells are still possible. 0, 0, not here, not here. Get a 0 here, and the last 0 in this cell. 2. 2 is not here, it's not there. That's a 2. One of them goes here. 5 is not here. In this row, 5 is down there, making this an 8. So that's a 3, that's a 6. And this is a 7, that's a 6. 1 can't be here. That's a 7. That's a 7. Here it's a 6. Disambiguating the 6-7 pair here. So really, this very neat logic was the turning point. 1, 4, and 8. 4 is not here nor there, so that's a 4, 1, 8. Non-consecutive is working very well. 3 and 4 by Sudoku, ruling out the left-hand scenario. Now here it's 2, 4, 2 and 4 don't go here, so this one is a 2. That's a 4. Let's put an 8 here. And for the final steps, 1 and 7 here by Sudoku. 5 and 8 here. And the last 2 digits, 2 and 6. And they don't produce any contradiction, any impossibilities due to some non-consecutive block. Non-consecutive contradiction, I don't know. Well, anyway, that was a very nice puzzle. There was somewhat very little to work with in the beginning, and to unfold it all was really a pleasure. So thanks, Lucy, for this very nice puzzle. Thanks for watching this video, and see you soon on SudoKanard.